right, so today we're going to be covering the distributive property. And so we have a expression here that we're supposed to simplify by using the distributive property. So what this means is this 2x out in front, we're going to take and distribute it to each term inside of our parentheses. So we'll take 2x times x squared, so we can expand this like 2x times x squared. We'll then take 2x and distribute it to our next term, this negative 4x, so we'll have 2x times negative 4x. And then we'll distribute it to the last term here, our 3. So then we'll have 2x times 3. And we can simplify each of these individually. So this x has an exponent of 1 on it. And if you remember, when we multiply variables of the same base, we add the exponents. So 2 times, there's a 1 in front of this x, so we have 2 times 1 is 2. And then we have x to the first times x squared, so we add the exponents, so 1 plus 2 is 3. The next term, we'll do the same thing. This has an exponent of 1. This has an exponent of 1. Each x in this term. So we'll take 2 times negative 4, which will be a negative 8. Then we'll take x to the first times x to the first, which is x squared. And then lastly, with this term over here, we have an x to the 0, because if you remember our 0 power, anything to the 0 is 1. So when we take 2 times 3, we have 6. And then we have our x to the first here. So we have x to the first times x to the 0. So 1 plus 0 is x. And so that's why even though there's no x term on this 3 at the end, we can still multiply, and we can still multiply these two terms together. So when we use the distributive property, this is what we expect to get. And the other example that I want to go over today uses the distributive property as well, but we have 2 terms this time. Okay, we have 2 terms this time. So we'll take each term and individually distribute it to each term, to the terms first. So we'll take our x here, and we'll take our x and distribute it to each term. So when we do that, like before, we would have x times x squared plus 6x minus 3. Then we'll take our 4 and distribute it to each term individually. So we'll have plus 4 times x squared plus 6x minus 3. And now we'll go from here and distribute just like we did in the previous problem. So we have x times x squared plus x times 6x plus x times negative 3. So that's what happens when we distribute this x throughout our expression. And now we'll take and do our 4 throughout the expression. So we'll have plus 4 times x squared plus 4 plus 4 times 6x plus 4 times negative 3. And now we'll just simplify like we did in the previous problem. So all these x's have exponents of 1. So we'll take x to the first times x squared. So when we multiply our variables together, we add the exponent. So we have x cubed plus, that x also has an exponent of 1. So we have 6 times 1 to be 6, and then x to the first times x to the first. So we add our exponents to get x squared, and then negative 3 times 1 is minus 3, and then we keep our x. Then we simplify over here, we'll have 4 times x squared to get plus 4x squared. 4 times 6x, 4 times 6 is 24, and then we have our x, and then 4 times 3 is negative 12. And now we can combine our like terms. So this x to the third doesn't have any like terms, so we'll just drop it down, x to the third. We have an x squared term here, and an x squared term here. So we have plus 6x squared plus 4x squared, so that will be plus 10x squared. We have a 3x and a 24x, so negative 3 plus 24 we'll rewrite as plus 21x. And then we have our minus 12 to bring down, so minus 12. So when we use the double distributive property, this is what we get.